Hello, everyone. This is Professor DePaulo, and today we're going to go through how to go through and navigate the practice lab for SPSS, and we're going to talk about Porto, which is the remote desktop to access SPSS from outside the school. So first, let me show you Porto. So you're going to log into Blackboard. And I mentioned this in class, but I'm just refreshing your memory. So I'm logging into Blackboard eventually in a year now. So we're having a little bit of a problem with the BMCC homepage again. So let me go the backdoor route. I don't know why the BMCC homepage is not loading again. So we're going to log into Blackboard, and then in your Blackboard account, you're going to have Uni Virtual Desktops. You're going to click on that, and then you're going to see Oporto. So we're using Oporto now for remote desktop. Log on to Oporto. It'll ask you to set up a profile. It'll take a few minutes. Do not refresh your screen. Just wait patiently for a few minutes while it makes a profile for you. And then after you do the profile the first time, it speeds you up to log in. So I don't have to wait that long after I've done it the first time. And I'm just going to log right in here. Okay, so now IBM, SPSS statistics. And I will be here in Oporto. So what I want to do is I want to now open everything into Oporto. So I'm going to go into the BMCC website, the Blackboard website, I'm sorry, for our class. And let's open the data set again. And if you already know how to do this and how to get into a portal, you can skip this, of course. This is our practice lab. I want that open. And I want the data set, SPSS lab practice data set. I go back to a portal, SPSS, and I want to have, let's get rid of that. I'm going to open up my Excel file. And so I have SPSS lab practice here. Save to the desktop, actually, but I can find it in my downloads file too. It should have been there. Hold on, let me download it here. So the problem with the portal is you got to download the files. Um, so you see the little cloud, it says file download. I got to download it from my PC. I don't know if I have it already. I think I do, but let me show you how to do that. So go into the download file that I just downloaded, or your documents, wherever you saved it. Okay, that's not it. Um, those are SPSS files. I don't want that. So I don't see any file on the download. I'm sorry, I have to upload it first. So let me upload from my PC. Not download, upload. Download is from the portal to your desktop. Upload is from your desktop to the portal. So this is what I just downloaded here on 12.8, the one I just opened. So it's under download file for your computer. So make sure you're doing upload first, not download. And now I'm uploading it. I already had it apparently, so I'm just going to replace it. So now that I uploaded it to a portal, I can open it up here in a Porto. And usually when I upload it to a Porto, it ends up on desktop. We look for Excel. And here it is. Ends up on your desktop. Now I should have the SPSS files up and ready to go for the exam. So this should not be an issue for the exam itself. This is just a problem with a Porto. You have to upload the file to a Porto first, then find the file and open it in SPSS. Then hit OK, and here's my data file. So now I'm going to look through the lab practice. So here's our lab practice. First question, I need to find mean standard deviation for depression, stress, and income. Depression, stress, and income. Let's look for mean and standard deviation for depression, stress, and income. Make sure you have mean and standard deviation checked. The rest of this doesn't matter, but make sure you have mean and standard deviation checked. And there's my answer. So here's our means for depression, stress, and income. Here are our standard deviations. So I'm done. Question 1 done. You're going to write it down. Question 2. What's question 2 say? Histograms for these 3 variables, mean, depression, 1, stress, and income. So that's found under analyze descriptives. And we're going to do explore. So explore gives you the option of doing both descriptives and plots. Whereas the descriptives, the one I just did before, doesn't give you the option for plots. So I got to use explore. And I'm going to just do these. I already have these means and standard deviations. So I'm just going to do plots. I don't want stem and leaf. I'll just do histogram. And I don't need box plots. So I'll say no box plots. I want histogram, not stem and leaf, and none of this other stuff. For statistics, let's get rid of descriptives. We already have that. We don't need the median, right? Or actually, it's not letting us, so we have to pick descriptives. So you can just ignore that stuff. Actually, I hit plots right here. So if I do display plots, it only shows me plots. I won't see the descriptive stats because I already have it. So I'm just saving time. So I just did plots. Here's histogram, depression 1 histogram, and it looks negatively skewed. Here's stress, it looks negatively skewed, tail to the left. And here is income, it looks positively skewed, tail to the right. So those are our 3 data sets, 3 variables. Okay, so that's it for question 2. Outliers. Oh, I forgot the outliers. So outliers I have to do through descriptives again. So to do outliers, let's do analyze, descriptives. The same thing we did for question 1. Let's do save standardized values as variables. I could have done that when I did question 1, but I've decided to show you a separate step. Well, you could do that when you do question 1. It's going to make 3 z-score variables. So it's done it already. Let's go back to our data. So if you click this little summation sign, here's our data set. Here's the 3 z-scores. Now, the easiest way to do this, as I said last time, is scan it. We're looking for anything above 2.58 or anything below negative 2.58. So for depression, this is the only one we have. K17 is an outlier. Nothing else works. For Z-stress, K17 is also an outlier and nothing else. So it's K17 for both the first 2 variables here, and for income, It's case 24 that's the outlier and nothing else. And as I said before, you could do this through select cases. If you want to do it through select cases, data, select cases, and you could do if. So we can do if depress one, and we do absolute value. So I can find that in here. You don't have to do this. You can just scan it, which is the easiest way to do it. But I'm seeing, okay, so it's saying I can't access this menu because, so I'm not going to access the menu right now. It's not letting me access the menu because of the connection is not ideal. Well, scanning is probably best. I'm not dealing with the best connection right now. Here's a portal again. Let me just save this. Let's just save this in case there's a problem. So I'll save it in documents here. You may want to save your stuff in a portal because, it's a remote desktop. So it's not like sitting at a computer with SPSS installed on it. If too many people use it or there's some kind of downgrade in the server, you get disconnected. So it's not perfect solution, but it is what CUNY is giving us. So I'm just saving the lab practice file, and it looks like I can't really save it right now. Save it later. So let's look at the next question. Significant correlation. So find correlation between depression, stress, and income. So analyze correlate by variate. Let's do depression, stress, income. Make sure you have Pearson checked. And then flag significant correlation. And I'm going to do show lower triangle so that you don't see duplicates. That gets rid of the duplicates. So it's show lower triangle. And then the asterisk will be for the significant. So you just have to look for the asterisks here. Hit OK. This is the lower triangle, so you have no duplicates, right? Obviously, the diagonal is just n. So you're going to ignore that. It just tells you 25 people are in each of the conditions here, in each of these correlations. So this first correlation, depression and stress, is 0.264. It's not significantly different from 0, so you're not going to asterisk it. Depression and income is negative 0.102. That's also not significant. And then stress and income is negative 0.038. That's also not significant. So all three of these are not significant, and therefore there's no asterisk for any of them. That's question 3. Question 4, does stress predict depression? Let's do the regression. Analyze regression. Excuse me for a second. Does stress predict depression, right? Is that the question? I forgot. The stress to predict depression 1. So stress is independent, depression 1 is dependent. Under statistics, you can just leave this the way it is. You don't need plots or anything. We're not going to do residuals. We're just going to hit OK. And here's my R. There's a correlation between those variables. This is the big R, multiple R. So that this pertains to 2 or more. So you can have 3, 4, 5 variables where you're correlating them all. That's what the big R is, the multiple correlation coefficient. We didn't really talk about that in class, but I'm just telling you what it is. R squared is important. This is the proportion of variance in depression that we can predict by stress. So this is 7%. If I make this a percentage, it's 7%. So basically what this is saying is that I can only predict 7% of depression scores by using stress as a predictor. And that's really poor because that means 93% of depression scores cannot be predicted using stress. That means you need more than just stress to really account for depression. Probably a lot more than stress. So this is a relatively poor model. As we can see here, the F value is 1.726. The significance value is 0.202. That is not less than 0.05. So what this is telling me is that this model does not show that the correlation or the regression is better than zero. Another way of saying it is that the regression line slope is not different than zero, which means a horizontal line. And when you have a horizontal line as a regression line, you have no regression. Because basically what you're saying is the best predictor of depression here is going to be the mean of depression. So your regression line is not offering anything over what you get by using the mean, which means that there's no relationship. It doesn't work. So this is not significant regression, which means that the regression slope, the slope of the line is not different than zero here. The regression does not predict anything. It's useless. This is not a good idea, right? So like if I got this in real life, I could add other variables as predictors. I can like make multiple predictors, and that would probably improve the model. But for this example, I want to keep it a one predictor because we're trying to keep it simple. And this one predictor is not doing anything. If you want to write the line, I mean, you still have a line, but it's just the slope of the line is not going to be significantly different at zero. So the line is basically horizontal because the slope of a horizontal line is zero. Here's the line. It's going to be 0.216 times x plus 43.196. So here's the slope, 0.216 times x. You're going to write x in there. Plus the y-intercept is 43.196. So that's your regression line. And it doesn't do much for you, but it's still there. It looks pretty horizontal. Let's see what else. What else is that question asking? Predict for a stress score of 85. So to predict for 85, all you're going to do is plug in 85 for x. So it's going to be 0.216 times 85. I could do that here. So 0.216 times 85 plus the y-intercept plus 43.196. And that gives you 61.556 as your answer for the predicted value. So when stress is 85, the depression score is 61.556. Okay. Next. Do illegal drug users differ from non-drug users in annual salary? Annual salary. Where's my statistics? So let's go to drug users. Let's go back here. So drug users are 1, non-drug users are 0, and I have that in the, it says it up here. Drug, 1 is it uses drug, 0 means does not use illegal drugs. So it's going to be 1 to 0. These are independent groups because you're either a drug user or not a drug user. You cannot be both a drug user and a non-drug user. So it's going to be independent groups, and we're going to compare those two groups. So we want independent groups t-test, and we're comparing them on salary. So let's salary. So analyze descriptives. Here we're going to want, actually, no, we're going to do analyze, compare means. Sorry about that. Analyze, compare means. We want independent samples t-test. And I want my grouping variable is going to be drug. And the two groups are going to be 0 and 1 because that's how I have it labeled, 0 and 1. And we're going to look at income. And we don't need effect sizes for this. Hit OK. Now we're going to use the top row because see how this is not significant. So this is looking at the homogeneity of variance assumption. Are the variances equal? And the null hypothesis here is that the variances are equal. And if it's not significant, then we stick with the null hypothesis saying the variances are equal. So therefore, we're going to use this top line. Now, I said you can look at whether the first variance is more than 4 times the second. Well, you can find that if you want, if you square these standard deviations, you can look at that. If you choose to look at this, it's going to be 900, and then 17 squared is going to be 3 something, probably, right? Close to 400, 3 something. And so that's not going to be 4 times the biggest is not going to be 4 times the smallest, but you can compute that if you want. So both of these will give you this first line. And the significance value here for this first line, I'm looking for a difference, and there is no difference. The two-tailed, so here's one-tailed and here's two-tailed. Two-tailed is 0.066. That's not less than 0.05. Therefore, there is no significant difference. I am looking at a difference, not a greater than or less than. So I'm using the two-tailed probability here, and that's not significant. So there is none here. So that's 5. 6, does level of education have effect on annual salary? And then do post-hoc test if this is significant. So if this first question is significant, there is a difference, then you're going to do post-hoc tests. If this first question is not significant, that means there's no difference, then we're not going to do these post-hoc tests. So let's see first if they're significant. Analyze, compare means. We want one-way ANOVA, and we are doing education and annual salary. So salary is income, and education is school. Don't need effect sizes. Let's just see if there's a difference first. Then I'll do the post-hoc test. And our F value is 7.375, and the sig value is less than 0.001. So that means that there is a significant difference between the groups. So there's 5 groups. There's 5 levels of education, and they're not all the same. So now we have to do the post-hoc test to see where the difference is. And that's what we're going to do. So let's do that. Analyze, compare means. I'm sorry, analyze, compare means. One-way ANOVA. Okay, that's good. Now here under post-hoc, you want to check off the first Tukey. So make sure you go to post-hoc, check off Tukey, and hit OK. And anywhere you see an asterisk means a difference, significant difference. So here it's between group 1 and group 5. What is group 1 and group 5? I have it labeled here in the lab. Group 1 is high school diploma. Group 5 is PhD. So there's a difference between high school diploma students and PhD students in the amount of money they make. That kind of makes sense, right? Is there any other difference here besides high school and PhD? There's a difference. Everything else? Oh, here's the difference. Number 2, which is, I think, some college. 2 is what? Some college and PhD. So there's a difference between some college and PhD because 2 is some college, 5 is PhD. For 3, there's a difference between let's see what 3 is. 3 is college degree and PhD. So there is a difference between college degree and PhD and the money made. There is no difference between master's degree and PhD or master's degree and anything else. And these are the 3 results we saw before. This is a duplicate here because it's 1, 5, 2, 5, 3, 5. We already did that. So these are duplicates. So we found 3 differences. High school, PhD, difference in salary. Some college PhD, difference in salary. College degree PhD, difference in salary. But nothing between master's and PhD. Also, interestingly, nothing between master's and high school, master's in college, sub college, and master's in college degree. So you're seeing the big difference with the PhD probably because of industry. So people with PhDs a lot of times they go into academia or industry. Industry pays better. People can make a lot of money in industry, and so therefore that's driving that difference. So there's 3 differences, and there's a total, since there's 5 groups, there's a total of 5 times 4 divided by 2 comparisons. So 5 times 4 is 20, divided by 2 is 10. So there's 10 total comparisons. 3 of them are significant, 7 of them aren't. And the 3 that are significant is high school, PhD, some college, PhD, college degree, PhD, and all the other 7 are not significant. So that's question. What's that? That's 6. So yes, and there's 3 differences. So I asked you here what levels of IV are significantly different. Those are the 3 I mentioned. And for not significantly different, those are the other 7 comparisons that you find in that chart. 7, the average annual income is 40,000 in the US. Is the average annual income of the sample, this is the sample, I should say, or actually, this is the US. So this is the population mean, it's 40. I took a sample and I want to see, does my sample annual income differ significantly from 40 for the population? So this is a 1 sample test because I have 1 sample and I'm comparing the sample mean to the population mean here of 40. So let's look at that. Analyze, compare means, 1 sample T. So I'm comparing it to 40. So I put 40 in this box. And let's look at income. Is it different than 40? Let's see. It is not. Non-directional is 0.360. That's much higher than 0.05. So the sample income is not significantly different than 40. And that kind of makes sense because the sample income is 45 and 45 is close to 40. So what we're saying here is that the sample of income at 45,000 is not significantly different than the population income of 40 that we're testing. So the sample fits with the population, if you want to look at it that way. There's no significant difference. So that's number 7. Number 8, does CBT have an effect on depression scores? Well, I can do that here. Analyze, compare means. Now we're doing before and after because depression 1 is depression level before therapy, CBT, which is cognitive behavioral therapy. And depression 2 is depression level after therapy. So we're doing paired samples. Move depression 1, depression 2 into this row. So you should have a row with depression 1, variable 1, depression 2, variable 2. And so we're comparing before and after. We don't need effect sizes for this if you don't want. Hit OK. And here we go again. Our t-value is 2.231. Our two-sided, our non-directional test is 0.035. That is significant at 0.05. So we can say that there is a significant difference between depression before therapy and depression after therapy. So therapy works. CBT works here. Before, the depression level is 57, almost 58. Afterwards, the depression level is 51. And that difference is significant. So that is a significant difference. And that is it. So for the exam, I'd like you to write the statistic values out, like the t-value, the f-value, the correlation value. Tell me what it is and give me the p-value, and then tell me if it's significant or not significant. And that's pretty much it. Write the regression line, write the correlations out. Everything else is self-explanatory. So hopefully this helps. You can use this for the final if you want. And if you have any questions, let me know. All right, bye for now.